We are recording. All right, so what we're going to talk about tonight is machine vision. Anybody deal with machine vision at work? Hey, we got one. What do you do?
I mean, if it's what I think it is, there's a camera that registers something, and you either are in or outside of the field of view, and then it checks that it's there or not, fault or no fault.
Absolutely. So machine vision can be used for a lot of different things. I will talk briefly about what machine vision's done. So as an example here, this is a sensor, a picture of an emitter and a receiver on a sensor. And what this sensor is doing is it's sending a beam. This is kind of like the sensor on your garage door opener at home. But in this case, if that lid isn't screwed down all the way, guess what it does? It breaks that beam, right? It faults, it kicks that thing out is what it does. Over here, though, is more of a machine vision example, where you see these tablets coming down a conveyor belt. They're going to go in a blister pack. And then you'll see this red bin over here with like broken tablets in it. And what it's doing is, if it senses that one of the tablets isn't complete, isn't whole, then it'll actually kick that tablet out, and then it'll go on to the next one and fill it up and do whatever it needs to do. So machine vision is exactly what you were just talking about there. It's decision making based on automated extraction of data. And what I would tell you is, if you're taking notes on this, these 6 categories are the 6 categories you ought to key in on for machine vision. These are the types of things I would ask you in the future on a test. So inspection, I think you mentioned it there, Nick. Go, no go, right? I can look at a part and I can say it's in spec or it's not in spec. It could be that I'm actually using a vision system to measure the part, or I could be just looking for flaws, kind of like those little tablets that we were just looking at a minute ago, looking to see if one of them's broken. I can also sort things. So as an example, if you've got a sheet of metal coming down and you're using a multi-stage punch or something like that, you maybe have some of the material that's your part and some of the material that winds up being scrap. The ability to sort the scrap from the part is a good thing to do as well, right? So we can sort, and we can use robots then to put the good stuff into the good bin and the bad stuff into the bad bin. But we can also sort by color, size, shape, any feature that you guys can view with your eyes. We can also sort using a vision system. We can measure, I think we just talked about that even on the go, no-go side, but we can measure size, position, features. We can measure angles. We can measure the diameter of a hole using a vision system. Material handling. So when a part comes down a conveyor belt, when you guys did the Scare a Robot project with the Legos, did it make a difference where that Lego started? Oh yeah, it made a difference such that you couldn't get it done. If that Lego was a 1/16 of an inch this way or that way, all of a sudden it's put in a completely different place, right? Imagine if you could instead use a camera to locate the exact position of the Lego and grab it precisely where you want it based on its current location, instead of depending on it being in a set location. So robotics, conveying, robot guidance is a huge piece of machine vision. Assembly, capping, filling. My Diet Coke bottle right here, I want to make sure the cap's in place. I want to make sure that it's filled to the right level. I want to make sure the label's installed. I don't want to hire somebody on the line to sit there and stare at Diet Coke bottles all day, right? Number one, they're not going to be as good as a machine vision system. Number two, these things are going to come so fast, they're not going to be able to inspect them fast enough to be able to do that. Identification, probably one of our biggest ones, text, barcode, lot number, stuff like that. That's stuff that we look at with vision systems all the time. If you go to like an Amazon distribution center, everything barcoded. You go to UPS, your Amazon fulfillment center, UPS distribution center. All these boxes come in, they get scanned from all sides. So you don't even have to have the box sitting in a certain orientation to scan it. It's going to get scanned from all 8 sides simultaneously, and they're going to look for that barcode and find it. So they don't have to flip it around or do anything like that. This kind of shows you some of these things. Presence, absence, you don't have to put this in your notes. Appearance defects, sorting, measurement, position, orientation, optical character recognition. That's a good one for your notes, OCR. OCR stands for optical character recognition, OCR. So when you drive into the airport, it used to be at the airport they would give you a little ticket. You put a little ticket on your dash when you parked in the ramp, right? And then when you exited, you put that ticket in the machine, and then it would scan it, and you'd pay your money. They don't even do that anymore. Now you put your credit card in the machine, it takes a picture of your license plate, it stores that with your credit card data, and then when you check out, it knows precisely when you came in, precisely when you left. There is no paper anymore. We don't have to worry about receipts or anything like that. That is what we call OCR, optical character recognition. You'll even see this on police cars that'll drive down the street, and as they're driving down the streets, they'll have cameras sticking outside of the cars, and they'll be scanning license plates as they're driving down the street. And that could trigger a stolen vehicle, some sort of all points bulletin or Amber Alert attached to that license plate, or whatever the case is. So I mean, it's really, really cool stuff. And then vision, guidance, pick and place, robots, all that stuff. All right, so what we're going to work with, and I'm not going to read this long statement, but we're going to work with the Cognex Machine Vision system. Anybody in here done the Cognex stuff?
We use that number, but I don't have a question.
Yeah, go ahead.
What should we write down for this?
Nothing.
Okay.
Nothing for this one. Yeah, for this one, it's just talking about what the Cognex Vision system is. So several of you guys probably see this at work if you use Vision. Anytime you see the yellow cameras, 9 times out of 10, you're talking about a Cognex Machine Vision system. So Boston Scientific in the battery line, they use a lot of Cognex. But they're everywhere. It's the biggest, just like Fanuc is, one of the leaders in robotics, and Epson is one of the leaders in SCARA robots, and Alan Bradley's a leader in PLCs. Cognex is a leader in vision. So we try to show you the stuff. I'm not going to read through that, but what it's saying is it doesn't matter what's coming at it. These vision systems can be trained to look at the level. It could be a little stain on the bottle. It could be a missing, whatever the defect is, we're going to be able to train this thing to identify the defect. You guys are going to be able to do that tonight when I'm done with this lecture. These are the vision sensors. I'm not going to get too detailed into this. This is actually a lecture I built for the automation and controls guys next semester, so I'm kind of test driving it on you guys right now. But you'll see the sensors have different levels of things that they can do. So a vision sensor can just detect presence, absence, and it might be able to do a simple inspection. A 2D vision system could guide a robot, could do some optical character recognition, could read codes, could measure and gauge things. And then a 3D profiler actually isn't showing all it can do here, but it actually can look in 3 dimensions and actually look at the profile of a part. So we get a much more accurate rendition of what's going on. Marshall?
Why don't you just always pick 2D vision systems?
All about price. It's all about price. So the 3D profiler is actually more expensive than the 2D vision system, and the vision sensor is much less expensive than either one of them. So it's all about price. You might be able to buy 2 or 3 of the vision sensors for the cost of one of these other sensors. So it's a much bigger difference. So if you don't need all the firepower, then don't buy it. We could be talking about some of these vision systems just for that camera alone with the smarts inside of it. You could be talking $2,000 or $3,000 just for that one thing. Versus if you do a vision sensor, you might be talking about $800 or $900. So you could get a lot of bang for your buck. And this kind of goes over all the details of all the different things that these tools are going to do, the capabilities. The cameras that we use in our lab are 70-10. We're not going to actually use a camera tonight. I'm going to give you the images that you're going to work with tonight, and then we'll use an emulator. So we'll set up the software like you're reading it off a camera. You just won't have a camera in front of you tonight. The images will come off your computer instead of off the camera. It's the same exact setup though. The power IO breakout, if we were wiring this guy up, we'd have to know where the inputs are, where the outputs are, just like a PLC. This thing has IO, so I can trigger it. So when a sensor gets hit, that's when it takes its picture. So imagine my Diet Coke coming down the line, right? When it gets within range of the sensor, that triggers it to take a picture. And then it inspects everything simultaneously, the level, the label, the cap, all of that stuff. This is actually what we'll do tonight. We'll do my Diet Coke bottle as our image tonight. So, all right, so what we have to do first, before we do anything, you guys have your computers open. What I want you to do first, I want you just to go to the Start menu, and I want to verify that you guys have a Cognex folder, Cognex. I see thumbs up in a couple locations. See lots of thumbs up. I see some head bobbing. That's a good sign. There are lots of things. What I want you to do is when you go into that folder, I want you to go down to, it's called Insight Explorer. I think it's probably, in yours, it's probably going to be 5 point something. 5.74. I'm going to open up a different one, but don't pay any attention to that. I just got a different one on my computer than you guys have. It's going to look just like this. When you open up Insight Explorer, it's going to do something like this. And it may ask you the same thing it's asking me right now. It's saying, hey, do you want to allow Insight Explorer? Yep, otherwise we can't do anything with tonight's lecture. Do you want to allow Insight? Yeah, I want to do that too.
Mine goes, when I click on Insight, it goes sample jobs, easy builder, spreadsheet.
So you guys can click on, did you click on?
Insight 5.7.4, Explorer.
Did anybody get to a screen that looks a little bit like this?
I don't have anything on the inside, but the windows.
Yeah, just everything grayed out with no smaller windows.
Yeah.
Oh, okay, good, good. So you've got the frame window like I have.
Yeah.
Inside.
Well, that's good. Yeah, the gray windows all look good. This one doesn't.
What did you go through for the subset? Easy Builder, Spreadsheet, Easy Builder. Or
So Insight, yeah.
Or 5.74. Go out. Oh, go back to Easy Builder.
Scroll down to just put Insight Easy Explorer. Is it Explorer?
No. Go here. Go to start. Go to the Cognex folder. Right? Oh, no. Yeah, there you go. Great.
Okay.
That looks
Like
Go
mine.
to Cognex. Scroll down.
Yeah,
down.
that's the exact same.
Okay.
Window.
All right, does everybody have a gray screen now? Something, it's going to look something like what I have, except you're not going to have the images like I do. So you've got the frame, and that all looks good. Now we have to do one other thing real quick before we can do anything. I got to remind myself, and I got it in the PowerPoint so I don't forget. All right. All right. So the first thing I want you to do is in the Insight Explorer, you're going to go to, I got to remember where it is here now. It's under, I'll find it. It's under System Options. Yeah. So under System Options, then you're going to go to Emulation. So hopefully you guys can get that far. Looks good? Now, down here, there's going to be a spot where it says like offline programming reference, offline key. You probably, does it have a number in offline programming reference?
0.
All zeros?
Or
Reference is
It's got a number?
B0E5.
Perfect. And then the offline programming key is nothing.
All zeros,
Okay.
exclamation mark.
Yep, so here's what we're going to do. Open up an internet browser, and I want you to go to Cognex.com. We're going to set this thing up. So under Cognex.com, I'm going to try to go slow. I don't want to get too far ahead of people. I want to go to Support, and just click on Support. Let's try that. And then under here, you'll see Insight Support. Let's try that. Kind of bouncing around here. We'll see if this works out for me. And I want the emulator, so I might even click on this little magnifying glass and just type in emulator. There we go. So on that was actually the quickest way to get there, is just that little magnifying glass. And then type in emulator. You see where it says Cognex Emulator Key Generator? That's what we need. Now, this is the one step that's going to take a minute, okay, folks? So what you're going to have to do is you're going to have to go in, you're going to have to create an account. Now, when you do this, use your first name, your last name, your country, your Dunwoody email address, create a password, try to remember what the password is, maybe even write it down. Don't use your bank account password. And then create your account. I'm going to pause the video here for a minute. So once you've created your account, you've activated your account via the email, and then now you're logged into your Cognex account, then you can actually go into this emulator, and you can actually go ahead and go to the key generator for the Insight emulator. So Insight Emulator Key Generator. And then in here, type in Dunwoody College is fine. But from the Insight window, where we just were, you need to take this offline programming reference, which is right here. That was under, if you don't remember what that was under options. And then grab that offline programming reference. You can copy it. You can go back to their website then. You can paste it in here. And I'm not going to run it on mine, but if you copy it and paste it in here and then hit generate key, it's going to give you a key. That key then needs to be copied and pasted right in here. And that key, when you hit OK then, that's going to unlock your software. Now your software is available to use. Why do they do this? Because they don't want robots, right, to go and start downloading and installing software, right? So you're kind of proving you're not a robot by doing all this chaos. But they're also getting all your contact information so that they can reach out to you for support with their Cognex systems, so on and so forth. So has everybody got that far done? We unlocked. Anybody not there?
It said you had to restart it.
Yeah, so all you have to do then is just X out of Insight, close out of that thing, and go ahead and go back and find the Cognex again. So Cognex, you want Insight Explorer.
You have to wait till it's shut down and it's complete.
Oh, that's right, because it takes a little bit to shut. Yeah, shutting down Insight. It's actually kind of funky. It takes a little bit for it to complete. But once you know that the shutdown of Insight is complete, then go back into Cognex, and this is where it gets cool, people. Go into your Insight Explorer. Now, before we go much further, I want to do one other quick thing. Well, that's opening up. Go ahead and open up Canvas. So go to our Canvas page for the course. And so under ING 4250, I've created some sample photos. So what I want you to do is under Machine Vision Demo 1, there's a zip file in here. Go ahead and download or save that zip file. Guess I can, what do I want to do? I guess I could open it, can I? Yeah, there it is. If I just click on it, it'll open. And then you can open it up. And what I want you to do is copy those, I think there's 7 images in there. Copy those images out of that zip folder. Those pictures are what we're going to inspect. And I want you to paste those images. I'm just going to throw them on my desktop. I'll create a new folder here. And I'm going to call this Demo 1. Or I'm going to call it Bottles, because these are bottles. I'm just creating a folder on my desktop called Bottles. And I'm going to paste those bottle pictures into that folder. So just throw those bottle images into that folder. So from the Canvas page, we have these nice bottle images that are available to us now. How you guys doing, okay? All right. Anybody falling behind, need more time? Looks like we're doing pretty good. So I got a folder with bottle images in it now. Now, under Insight Explorer, this should hopefully be open again now. You shut it down, you reopened it, and I don't know if it's got a different, do you get any of this stuff over here now? Okay. What I want to do is we're going to instead of, now what we could be doing is we could be connected to a camera, right? You see it goes through the steps, step 1, 2, 3, and 4. These are the steps to set up a machine vision system. Steps 1, 2, 3, 4. Now under Get Connected, we have one of two things. We're either Ethernet connected to a camera, which we're not, okay, or we're going to get the image from an emulator. So what I want to do is down in the bottom left, if you're in Get Connected, I want to click on where it says Emulator down at the bottom left. And then where it says, there's lots of options. I don't know, does it give you options there?
Yeah.
Just pick standard. All right? And then there's a sensor and a PC button right here. So we selected Emulator Standard, and now we're going to select PC is what we're going to do. Make sense? Then we're going to go to Setup Image. So step 1, get connected. We got it. We got the PC. We got the emulator. Now we're going to go to Setup Image. Under Setup Image, we're going to load the images from our PC. So on the bottom left here, there's a button that says Load Images from PC. I'm going to click on that. I'm going to go find that folder where I saved those images. So for me, it's on my desktop, and it's in the bottles folder, right? So I click on desktop, I click on bottles, and I click on OK. Then I click on OK again, and guess what shows up in my images? I'm going to take a quick walk around. That's good, that's good. Oh, I see lots of bottles coming up. Bottles, Marshall, got a bottle? And Elsie has the wrong image.
Yeah.
You got to go back and get the bottle images. You got the candy images, so I think that was demo 2. We'll do that one second. So just go ahead and go into the demo 1 in Canvas. Open that up, copy those files, place them in a folder called bottles, and we'll wait on Elsie, and then we'll get going here. There we go. All right, so now what you're seeing right now is the first bottle image. Now, does that bottle look good?
Yes.
Well, we don't really know what a bad bottle looks like, but if you click on these little, you see these little yellow arrows? If you click on this little double yellow arrow to play next, the bottle kind of bounces around. Now, what's wrong with that bottle?
Empty.
It's empty. What's wrong with that bottle?
Bad seal.
The seal is broke. What about that one?
Crooked cast.
The seal is cross-threaded on there, right? How about the difference between this one and this one? This one and this one. The level of the soda is too low on this image. So what we need to do is we need to set up a system. Now, we could be doing this right now, like I said, with a live camera. We could have a camera on a conveyor belt with these coming by one, and it would look just like this. Every time a bottle got within range, it would trigger the camera. The camera would take this picture. How do I know that? Because that's how these pictures were generated. They're generated from a camera. These are just snapshot pictures off of a vision system camera. So we can go through them really quick, though, and kind of see. Like if this was at Pepsi or Diet Coke, they'd be coming down that line like this, right? You might be looking at hundreds of bottles a minute. I don't know if you'd be looking at thousands of bottles. You'd for sure be looking at hundreds of bottles a minute, right? The first picture, we're going to call that our good image, is what we're going to call it. All right? So now we're done with step 1. We got connected. We set up the image. Now in step 2, we're going to locate the part. So click on Locate Part. Now what does that mean to you guys? What does Locate Part mean?
Figure out where it is.
Figure out where it is. Yeah. If I don't know where the part is, how can I take a measurement, right? So the camera is very specific. If I'm going to measure the level of something, I have to have a datum. What's a datum?
Starting point or
Yeah, it's like, if we're talking about like a vise, it might be the fixed jaw of a vise, right? That might be our datum. Or if we're talking about calipers, it might be the fixed jaw of the calipers, right? That's the measuring reference to which we measure everything, right? So we need that datum in a vision system as well. So what we're going to do is we're going to locate that part. Now there's all kinds of fancy tools down here. I always tell people I want to do it with the most basic tool. The reason why, I don't know necessarily right now with the emulator, I don't know what camera I'm going to hook up to. I may be hooking up to the least expensive black and white generic camera, or I might be hooked up to the fanciest vision system on the planet, right? But if I can do it with the least tool, it'll work on all the cameras. Does that make sense? So I'm going to grab not PatMax Redline or PatMax Pattern. I'm just going to grab the one that says Pattern under Location Tools. So like this Location Tools, there's one called Pattern. And I'm going to add this tool. Now before I do it, it gives me a description. It says locates a single pattern feature, reports the XY coordinates, angle, and score found pattern. Outputs a tool fixture that can be used to reference by other tools. That's a datum, isn't it? It's a reference. So I'm going to click pattern, I'm going to click add. Now it gives you directions down here. It says first position the model region directly over the model pattern feature, then position the larger section region over the areas in which the image of the model pattern may appear. So what it's saying is, it's saying, look, this pink square, we're going to try to pick apart, we're going to try to put that square around a part or around a feature that's always there. Like that. Maybe like this 90-degree bend of the cap. I'm expecting every bottle to have a cap, and every cap should have that left-hand 90-degree bend. Shouldn't it? Pretty simple, right? So that I'm going to use that as my datum or my fixture. Then this outside green one, I can move around as well. But before I do that, this outside one, now mind you, when I click on one, it turns colors, right? So the model one, I can zoom in and look at it. This inner one's called the model, and the one on the outside is called the search. What do you suppose the search does?
Search area.
Yeah, this is my region of interest. I'm going to look for that model in this area. And the reason why that search is important is because if I scroll through these, what does the bottle do? It moves around, doesn't it? So I'm going to build this based upon my best image, which is this image right here. But what I can tell you is my search area, the bottle never leaves that outside rectangle right now, does it? Now really, I should try to make that outside rectangle kind of representative of where I'd expect that to happen so it doesn't have to look as far. But I don't want to make it too small because I've only got 7 images here, and it's possible that in a future one it might be further to the left or further to the right, right? So I'm going to leave it pretty big so it can find it. So now I've created this little model region right here. When I hit OK, as soon as I hit OK, yeah.
You're using the low-level image right now, the low liquid level image.
Am I?
Yeah.
Well, I don't want to use the low-level liquid image. Is this one better?
Left one is the best one. The first one in the series is the best picture.
Oh.
Or are you zoomed in? Oh, you're
Zoomed in.
Okay.
I'm just zoomed in.
I got you.
Yeah, I'm just zoomed in. Whew, you scared me there for a second.
Scared me for a second.
We're good. We're
I
good.
run low into IO.
Whew. Yeah, this one's got low level right now. But anyways, okay. So I'm going to hit OK. And what that did is you'll see down the bottom right now, this is the pattern it's going to look for in every image. Do you see the little crosshairs on your bottle there? As I rotate through these images, those little crosshairs should show up in the same position on every image. And it does. Except for, oh, it does.
You're the one that tilts, just changes.
The one that tilts just tilts with it, doesn't it? So that datum or that reference actually rides around. No matter where the bottle goes, it rides around, doesn't it? That's really nice because we can use that as our reference for all of our measurements. All right, so now what we did was we located the part. That was step 2. And the bottle's connected to that cap. So we've got the bottle. We know where the bottle is now. You know, it's just like if you're measuring something with a set of calipers. You know, if you can't see the part, you can't measure it. Now where we know where the part is, we can measure based upon that, right? So now what I'm going to do is I'm going to inspect the part. All right, so that's my next step, is to inspect the part. Now realize I'm giving you guys like 2 hours of machine vision training, right? So other than Nick, nobody in here will be an expert, but he will be. So there's all kinds of tools down here. There's presence absence tools, there's measurement tools, counting tools, identification tools, so on and so on and so on. I'm going to use a fancy trick that I use to look at that cap. Is I'm going to use the measurement tool. So under measurement tools, I'm going to use something called Blob Area. Now what do you suppose blob means? This is a fancy vision term. It's a cluster of pixels.
Darker like other pixels.
That's it. That's exactly how you clicked on it.
Preferably connected.
Yeah, so measures the area of a single group of dark or light colored connected pixels called blobs. Reports the area in pixels unless the image was calibrated as setup image. So we're going to use this. So I'm going to go ahead and click on Blob Area. Again, I'm in the Inspect tool part, and then I'm under Measurement Tools. Blob Area, I'm going to add it. Now the neat thing about this is I'm going to draw this only around the cap. Now you might say, but EJ, the bottle moves. But guess what? Because we located the part, the tool is going to move with the bottle now. Does that make sense? So the tool is going to go with the bottle no matter what I do. So now I'm going to measure the blob area. So first, from the region type drop-down menu, select the type of region, and then position the region over the area where the blob feature may be located during inspection. Once you have configured the region, press OK. So I like the rectangle shape. I don't need to do a circle or a polygon or anything like that. I'm just going to go ahead and hit OK. And now I'm going to get blob area. Now it gives me another little crosshair, like a little origin of the center of the blob area. So I've got this origin up here which locates the tool. And this origin which tells me the center of the area. Now look on the right hand side. Do you see the pixels? 17,158.998 pixels. Seems like a good deal on my good part. Now if you go back down to the bottom down here, I'm going to make mine a little smaller. In settings, the blob color is an important thing. We don't want to look for either light or dark. We want to look for black. I said light or dark. It's actually black or white in this particular case. We want to look for black pixels. That's what we're going to look for. And then I'm going to have a minimum area and a maximum area. Yeah?
I got kind of lost with the step before.
The blob area or the original one?
The blob area.
All right, let's do this then. Let's run through it one more quick time.
Sorry.
No, you're fine. Now once I have that blob color set to black, what you'll see over here is it's going to give you the result, the area in pixels of that cap. Now as a rule of thumb, what I like to do is I like to set under range limits, I like to set a minimum and a maximum. And they actually do a little bit there. They might do like a plus or minus 10%. I'll just leave it. I think it has 17,158. And it goes up to 18.8 and down to 15.4. That's what it's going to consider its inspection criteria. Now, if you scroll through the images, do any of them fail?
Yes.
That one fails. Why does that one fail?
Because the image or the blob isn't connected.
Correct. So as soon as I break that seal, I no longer have one solid blob. I now have two blobs. And what it's going to do is it's going to pick the largest blob in that inspection area. And it's only going to measure that one. In this particular case, it said, guess what? It's 11,913. That's not good. That's outside my region, right? And if I do another one, that one passes. I guess that's the only one that fails, is the one that's disconnected. But that's something we want to fail, right? Makes sense. So I like that. Now we got other issues, though. We got one that's angled, and we have a bottle that's not filled, right? So we got a couple of concerns that we got to overcome that are beyond just, we've managed to find one problem, but we didn't find the other problems. All right, so I'm going to stay and inspect part, because I'm going to do a couple more inspections. The next inspection, I'm going to make sure I'm on that first image again. So go back to that first image in the film strip, because we know that's our good one. Under Inspect Parts, let's see. There's a measurement tool. I'm going to measure distance. Why do you think distance might be a good one to look at?
Distance from the cap to the top of the pot.
I love that. So the soda level can use the cap itself as a reference, can it? And that distance is going to be measured in pixels. So you guys might be measuring, your parts in the machine shop in, tenths or hundredths of a thousandths of an inch, right? Now in this case, we're going to measure that distance in pixels. Why? Because that's how digital processing of images works. It's all about pixels. So I'm going to go to distance, It says measures the distance between any two features. Angles, blobs, patterns, circles, edges. Reports the distance in pixels. I say, that sounds good. I'll hit add. Select two features from the available smart features. So I'm going to make this image a little bit bigger. And I might even zoom in a little bit on that image. What you're seeing is it's saying, look, these blue lines are what we call smart features. And what it's going to do is it's going to say, look, I found an edge. Pick the best edge you can find. So as an example, this edge here is a nice long flat edge. I'm going to click on that. This down here is a nice long flat edge. I'm going to click on that. I'm going to try to draw a straight line. Why? Because if I draw it at an angle, yeah, my distance isn't going to be vertical, right? So I'm going to click on this edge now. Now, as soon as I do that, I get an edge, and a distance in pixels. 196.8 pixels. All right? Now, if I scroll back down and look at the bottom down here under my tools again, you'll see I got distance, settings, midpoint to midpoint. I got range limits. I'm going to leave those in. Again, Cognex kind of tries to make the decision for you. It gives you a plus-minus factor. I hope that that's going to be good enough to do what I want. So what I'm going to do now is I'm going to use that distance measurement. I'm going to zoom out a little bit so I can know what bottle I'm looking at. And I'm going to scroll through these images. That one's good. And I'm looking over here on the right, 196.8 pixels. That one's good, 196.8 pixels. That one's bad. Why? There's no liquid. So couldn't find an edge for liquid, so it's going to fail it. Do we want that bottle to fail? Absolutely. I'm going to go to the next image. This one failed. Now, why do you suppose this one failed? Yeah, so it's something about the way the cap is broken there, the seal is broken compared to the liquid. Yeah, I'm fine with this failing. Now I will let you know, I could if I wanted to, because I think this one might pass if I was to take this little box, see this little box down here? If I was to click on that box, I could actually pull it up a little bit. I could probably find an edge. See how I pulled that top little edge of the box? I did like a little resizing of that box, and I did find an edge. Now, I would have been fine with that thing failing, but that's not the reason it should fail, right? The liquid level is not the reason this bottle should fail. This bottle should fail because of the seal, not because of the liquid level. All right, now I'll go to the next one. The next one also failed. Now, this one definitely should fail. Why? Because now the liquid level's correct, but because the cap is pried off like that, I'm getting a distance over travel, right? The distance is 211 pixels, and my range, I gotta go back here, my range is only to 206. So you could also dial these in. Like if I click on this distance measuring tool and then go to range limits, I could say, you know what? I want my maximum to be 205 and my minimum to be 185 or something like that, right? You could set those to whatever you want and determine how much of the cap being unscrewed would cause this, right? Or how much liquid level. Like if I go to the next one now, this one fails as well. Now this one fails for what we're trying to measure though, doesn't it? This is exactly why we created this tool. We wanted to measure the liquid level. And so in this particular case, it makes perfect sense for this one to fail, right? What do you guys think? Pretty cool? Awesome. All right.
Is there a way to edit a tool after you already have it in there? Like say I should have chosen edge for the distance and I wanted to choose a different edge instead.
Yeah,
Delete it and start over again, or is it just, can you?
You want to delete it and start over.
Yeah, I would agree with Jeremy on that. I would just delete, and the problem is now you've actually got kind of three tools there. You got an edge, and a distance. So you kind of got to delete all three of those now and just start over. It'll be a lot kinder to you. I've been able to edit some things and make some things work, but It's kind of like as soon as it's like skinning an onion a little bit, you peel a little bit back and it's like, now I screwed something else up, you know. There's another layer behind that that's screwing it up now. So now the good news is all we wanted to be able to do is detect the bad bottles, right? This one's good, all green. This one's good, all green. This one's good, all green. This one's bad. Well, it darn sure should be bad. There's no liquid in it. This one's bad. For a different reason, the blob area failed because the cap is separated into two pieces. This one's bad. Why? The angle actually created a distance between the liquid and the cap that's too great. I probably could have found that with an angle of some sort too, but this worked for me. This one failed because the liquid level's too low. So we've got it now where it fails or passes based upon exactly what's going on. Now the only two things that fail, I fail distance or I fail blob area. Distance or blob area. Those are my two main tools, right? And that's what I want to have happen is I want to be able to tell something is passing or failing. All right. Now I want to do one more thing. We won't do communication. Communication would be, or inputs, outputs, would be if I wanted to send this data to a PLC, or if I wanted to send this data to a robot, right? If I want to send this data to a robot, or to a PLC, or to anything else, even just a pneumatic actuator that's going to kick it off the line, I need to set up inputs, outputs, or communication. Those are the only ways to do that. Now, we're not talking to anything, so we're not going to do that. But what I do want to do is I want to create one thing that says pass or fail on the screen. So I'm going to zoom in a little bit in here. And I'm still in the inspect part tool. All right? This one's going to be a little funky because we're going to probably have to do a little bit of programming here. Under math and logic tools, let me think here real quick. I want the string tool. Maybe it's under plot tools. Yeah, it's under plot tools, I think. All right. So under plot tools, I want you to grab the string tool. What is a string? Piece of yarn,
Yeah.
piece of rope. That is a string. I agree.
Line.
Yeah, a piece of line. A string in our particular case is a sequence of digits. So kind of like an integer is a whole number, a floating point number has decimal places. A string has alpha and numeric characters to it. That's what a string means as far as the data type's going. So we're going to select this string tool, plots a text string graphic on the image based upon mathematical instructions. Requires location inspection tools as inputs. Add and configure those tools before adding this tool. Well, we've got all of our tools in there, don't we? So I'm going to go ahead and click on this string tool. Add it. Now this is the tool I like the least out of all the tools in Cognex Insight, but we're going to make it work. So the first thing about the string tool that's a little bit goofy, if you look up in the upper left, you'll see like a little cross here up in the upper left. That's telling you where the string is going to land. Now I don't want it to land in the upper left. I want it to land maybe next to the cap here. So you'll see this X and Y tab down here. Let's set the X to something like 75. See it moved over? Set the X to 75. And if you set the Y, if you click on the Y tab and set the Y to 150. And then move down. Why do I know exactly where to set it? Because I've done this lecture 1,000 times, haven't I, Jeremy? So now I've got this right where I want it. The little bullseye is kind of right next to the cap. I like where it's at. My X, 75, and my Y, 150. I shifted it over 75 pixels. I shifted it down 150 pixels. And now I'm going to generate a string. So now I need an expression that I'm going to use with the string. All right, so now is where I got to get kind of fancy here. Let's see here. So I got text, string, code. Let's see here. Logic. Ooh, I like logic. So there's the vision tools, there's the mathematics, and then there's logic. Logic makes sense to me, right? I'm going to ask a question. That's what logic means. I'm going to ask you a question. Is this true? Yes or no? So what I'm going to do is I'm going to go under logic.
Where's logic at?
So under the string tab,
Yep.
there's the vision tools, and then there's the math tools.
Yep.
Go into the mathematics tools,
Yep.
then text,
Oh, there's first.
then string, and then logic. Or excuse me,
Wait, it's just mathematics logic, right?
damn it.
Yes. Yep.
It's mathematics logic, yes. I just put damn it on my video. That's okay. We're all adults here, right? So mathematics, logic, and then I want to do if. Now, nice thing about this is just like everything else, if you mouse over if, it says if condition returns val1.
Mine's grayed out.
Oh, your if is?
Yeah.
True, otherwise return val.
Yeah.
Did anybody get it to work? Oh, Marshall's got it working.
I have mine over, I'm hovering over it and gives you the description.
Yep. Are you under the right tab?
So you're in the string tool,
Click on your first image.
mathematics,
I'm on my.
logic, if. I'm going to pause the video. All right. So here we go. So now what we're going to do is we're going to bounce into this if tool. Now I want to take a hard look at this before I do it though. I'm going to mouse over this if tool and it says if condition return value 1, otherwise return value 2. So I'm going to double click on if. All right. If condition. So now I've got all these extra things I can look at, right? So under blob area, I can drill into this right here. I can drill into blob area, and I wonder if there's a blob area pass.
There's a pass, yeah.
I think so. We'll pick pass for blob area. So then it'll actually, you'll see actual code. And you used to have to remember these things and be able to type them in. You don't anymore, which is nice. If blob area pass, now here's a little cheater on old school Boolean logic here. You type in a double ampersand, so it treats it like an AND gate. If blob area pass and what's the other thing we need to pass?
Distance pass?
Distance. So then I'm going to go to distance tool. So I uncheck the blob area, go down to the distance tool, and I'm going to guess distance has a pass. It does. If blob area pass and distance pass, I don't remember what to do with an if. I think comma, type in the word pass. Ooh, that was kind of crazy. Comma, pass, comma, fail. That did not work. Yeah, two and signs.
Okay. Sorry, I'm blind.
Yeah, let me,
Any space?
well, I definitely have a problem here.
Quotes. Yeah, quotation marks.
No.
Oh, it might be quotation marks. No, it's not that. Hold on. It's going to be one of these. Pass. Well, somebody, who said quotation marks?
I did.
Good job there, Jeremy Berg.
You were the one that taught me it.
Yeah. So I'll bounce this up on the screen so you guys can see it. This is what it's going to look like.
Zoom way into, whoa, okay, I see.
Does that help?
Yeah, that helps a lot more.
A little easier to look at than what I was trying to show you in that little tiny window there.
Yes, it's kind of like they did statement.
Yeah.
So basically, if blob area 1 pass and distance 1 pass, then we're in display a pass. Otherwise, we're in display a fail. And remember, these are colored. I selected them. Those are out of the tool. I'm not going to type that in. You could type it in. And then once you're done with that, so just realize it's a comma, and then quotation, pass quotation, comma, quotation, fail quotation. What does those quotes mean? It means you're going to display a string. And this is the string that you're going to display. You're not going to add a number. You're not going to display a number. You're going to display a string. You're going to display some text. Now the craziness is, if I go ahead and hit enter, it's working. But if you look in here, look at how small it is. It's tiny, isn't it? So we can go into settings for this tool, and we can change the font size to something larger, like 48. And now, and I might even bring my Y up a little bit now. I might bring my Y up to like 125 or 120. And my X over to 50. Something like that. So I'm just kind of moving it around a little bit. I don't like where it was sitting, so I'm just going to move it around a little bit. And you can change the color. And now, if I scroll through these images, I'm going to zoom out a little bit. But if I scroll through these images, pass, 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 fail, 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 pass, pass. What do you guys think? Is that the coolest thing ever? Told you guys that was going to be the coolest thing you've ever done. That is pretty darn cool. Now, it wouldn't be a bad idea at this point to go File, Save Job As, Save Job As, and then it's going to save it wherever it's going to save it. I could save it somewhere else. If I wanted to go back to my desktop, let's say, if I want to go into my desktop and go into the bottles folder, if I want to save that job in there and say, call this the bottle inspection, now I have the pictures in one folder and the inspection I'm going to use to inspect them, right? And assuming that I was working with a genuine camera, the steps are exactly the same. They're exactly the same. Jeremy Berg, what is the most important variable when dealing with machine vision systems?
People.
Lighting, lighting, lighting. It's all about lighting. If you can't control the light, you will not be able to process the images. If the light changes, your inspection tools will stop working. Boston Scientific has a story about that.
We've got a flag up in our machine shop covering a light.
Do you really? There was a story, there's been countless stories where people have changed the light bulbs in a room, and now all of a sudden their vision systems stop working. So you'll see a lot of times a cell that has a vision system in it, many times what they'll do is they'll smoke out the windows of that cell. So if you look at these robots, imagine all that plexiglass smoked out black and then lit from the inside. So we're not dependent on ambient light. We're lighting it up from the inside. And the other thing too is the cameras have lights on them. We can flood that part with light as we're taking the image, get our good image, and then turn the light back off again, right? So that's the best way to go. All right, I'm going to pause the video one more time. Hour left or so, so this will go pretty quick.
I did a new job and all my pictures are still in here.
So here's the deal.
What?
Go to Dice on Canvas. So on Canvas week 15, demo 2, you're going to find a folder that says download Dice Zip. We're going to go into that folder, just like we did on the other one. We're going to grab that chunk of photos. There's 9 of them in there. Did you find Dice? Where did you find the candy one, Elsie? Oh, it's the lab.
Can't tell you what I got.
The lab is the candy one. That's right. All right, so we want the Dice one. Create another folder on your desktop or somewhere you can find it easily. I'm just going to create a folder called Dice. I'm going to go into that folder. I'm going to paste the Dice images in there. So I got bottles and I got Dice. Give you guys about a minute to get caught up, but make sure you got that folder with Dice in it. I actually think I probably did these in reverse order because I think this one's actually easier. than and this is one where these images are images off of one of our cameras. This is a job that you actually do, right? Jeremy, you guys did the dice in the lab?
Oh yeah, dice was easy.
Dice was easy, and so this one should be pretty easy as well. Go back into the Cognex folder. We're going to start right up at the top again. Get connected. Under Get Connected, I want to make sure my emulator is set. I'm going to leave it on standard. I could have it emulate the actual camera I'm using, but I don't know what camera I'm using, so I'm just going to leave it on standard. I'm going to make sure I have PC selected. Then I'm going to go to Setup Image. Oh, before we do this, though, you know what we should do? We should do a new, right? Because I got all these tools sitting over here, don't I? Let's go ahead and do a new job. Yep, I want to clear all the data from the current job.
Isn't data pictures?
Yeah, except they stay. We'll get rid of them right now. We'll get rid of them right now. So Get Connected is good. We're in the emulator, standard, PC, Setup Image. That's where you're going to load the images from the PC. So now when I go to load images from PC, instead of bottles, on my desktop, I'm going to go to the dice folder and hit OK. Now, hopefully, instead of bottles, now you're seeing dice. I like it. Now, it's a good idea to kind of figure out how you want to orient your menu or your screen. You know, maybe you want to zoom in a little bit, scroll down, scroll through the dice and kind of see what you've got. Kind of scroll through them. Looks like I'm just hitting all the different dice is what's going on there. Dice, dice, dice. Did Marshall fall down?
No, I'm probably plugging my computer in.
Oh.
And the chair just fell.
Thought Marshall wiped out back there. All right, that'll be on my video forever, Marshall.
Good.
All right.
Famous.
All right, so I'm going to make sure that I can go through the dice. I can see all the images. Nothing surprising there. They all look pretty good. I'm going to go ahead and put it on the first one. I'm going to use that first dice as my sample image, or my starting image is what I'm going to do. All right, so setup image is done. Again, this menu takes you right through the steps. The easiest thing in the world. Next thing I'm going to do is locate the part. What does locate part do? Anybody remember? It locates the part. Exactly right. We're going to do the same thing we did. About 9 times out of 10, you'll use a pattern tool or an edge tool to locate the part. I'm going to use the pattern tool again. So step 2, locate part. And again, this is going to locate a single pattern. So I want to go ahead and add that tool. Again, the green represents where it's going to look. The purple represents the pattern I want to look for. Now, I've tried different things in the past. I just want to try this because I don't know if it'll work. I always do a corner, but I'm just going to, for the sake of sake, I'm just going to try and see, could we pattern the whole die?
Yeah, I did the entire cap in the last one worked out pretty well.
Did it?
Or not in the bottom half where the little lid was.
Yeah. I'm going to try to pattern the whole thing here and just hit OK. Now, this may or may not work. I don't know. I'm going to go ahead and hit OK. Now, you'll notice when I did that, where did it place those little crosshairs?
Center of the die.
Right in the center of that die, right? So that's kind of cool. Now I'm going to go ahead and scroll through the images. Does it stay in the center of the die on all of them?
No. Just the one.
How come die number 6 is giving me a hard time?
Because there isn't. Oh, no, that doesn't. Never mind.
I actually don't know.
2 is giving me.
So I could go into settings and I could look and I could change some things if I wanted to. Like if accuracy is medium. Maybe under accuracy I want to go to, no, I don't want to go to more accurate. I'm not getting it that way.
I actually set it to look for the edge, like all of the entire edge of the.
I know, I was trying just to do the whole thing, but it didn't work.
I excluded the middle section.
There's a rotation tolerance too, that could be part of it.
You know, I also could do the accept threshold You can, oh, check this out. If you bring the accept threshold down, the accept threshold's at 50. If you take it down just a little bit, down to like 40, all of a sudden 6 comes in just fine. So the accept threshold is going to say, okay, I'm going to only accept something that is, I actually can't tell you exactly what the accept threshold is, but there's a number associated with it. There's a score, right? So if the score is 50 or better, I accept it. But now I'm saying if the score is 40 or better. Now if you look over here, you actually can look at that score, I think. Yeah, it says score equals something. I can't read, it's off my screen, but
all my other ones fail now.
do they?
Yeah.
All of mine pass.
If the accept threshold low enough, it should pass it.
6 comes in at 46.1 for the score.
Because the difference in the white. That's why you went with that outside edge.
Yeah.
The difference in the white.
What you can do, if you're unsure, just delete the pattern tool. Just delete that pattern tool. Go ahead and do it again. I'm going to do it this time. I'm going to pattern. And I actually like modeling off the whole thing. So I'm going to still model off the whole thing. I think that's kind of cool. I am like you, Jeremy. I like to pick a corner or an edge. But I just wanted to try this, and it actually surprisingly worked for me. So I'm going to go ahead and continue with it. So yeah, so now I've got the middle. It's hitting on all of them, except that 6 is weird still. But if I change that accept threshold on the 6.
Is it because there's a dot? Or
Is it because there's more black than white?
It could have something to do with more black than white. It could have something to do with the orientation of the die. There could be a couple things. But I just bleed that accept threshold down to a point where it scores. And now all of them score. Now I like it, right? All right. So now I've got that working. I feel pretty good about it. So what I'm going to do next is I'm going to go to inspect part. I've located the part. Now I want to do an inspection of the part. So that's the next tool in my list. Now what we want to do is if we want to display the number on the die, any guess what we might want to do? Counting tools. What do we want to count?
Blobs.
Let's count blobs. It's a really technical term, isn't it? Count blobs. So it counts the number of groups of dark or light colored connected pixels called blobs present in a region of the image, reports the number of found blobs. I like it. I'm going to add that tool. Now what's the problem?
It's out of range and something.
Yeah, I now need to tell it where I want to look, right? And remember, it's going to use that fixture. It's going to use that location tool as the fixture. So if I draw it around here, and if the fixture is the center of that die, it's always going to draw that box around the center of the die, right? So I'm going to be okay with that, and I'm going to hit OK. As soon as I do that, looks really, really good, except how many blobs is it displaying?
4.
Now zoom in on this thing and let's find out why.
Is the white is a blob too?
Yeah, what do we know? Why would the white be a blob?
Color is technically a blob.
It is a blob.
Because we're picking up either white or black.
We have both white or black blobs. God, I can't say that 5 times really fast. We have either white or black blobs available to us. We don't want both of them available to us, so under settings, what do?
Change the black.
Change to black. How many blobs do you get now?
Mine shows up with the red X now, but it's showing 3.
Showing 3. That's fine. Let's go through them and make sure it counts right, and then we'll talk about the red X. So I got 3. I've got 1. I've got 3.
4 is good.
I've got 5. And again, I'm looking over on the right here. You see where the 1 shows up on the result? That's what you want to look at. I get 6. I get 4. This was way too easy. Come on. Seriously? All right, so these are working great. Now, the reason why you're failing, why the step is failing, is look at your range limits tab. What did your range limits tab do? It said, well, I read 3, and I put in these automatic ranges of like plus or minus 1, right? Except it's not plus or minus 1. What should my range be?
6
1 to 6. So my minimum should be 1, and my maximum should be 6.
There's a dandy little tool you can press. It's called auto limits. It comes up with 3 to 3.
That's nice.
Just the number 3. Nice.
I'm gonna have one, but it doesn't know you're inspecting a die, right? It thinks it's inspecting maybe a gasket, and you're always expecting 1 hole, right? So I'm not gonna look for 6 or 3. In this case, though, now all of them are showing up green. I really, really like that. Now it'd be nice if we could, at this point, find a way to display that on the screen. Now, I will warn you guys. Exactly right. But we don't do this in the real world. We don't display it on the screen in Cognex Insight. Where do we display it? On the HMI. On the touchscreen HMI. Or, on the robot controller, or on a different display, right? We're not going to display it on Cognex. We're only doing it this way because we're using the emulator tonight. But normally my next step would be to go to communication and say, hey, I want you to send the blob count to the PLC so the PLC can display it on the HMI as N007, right? That wouldn't have made sense to you guys at the beginning of the semester. For some of you, it probably still doesn't make sense. But for most of you guys, you're like, oh, yeah, I remember N007. Those are integers back in RS Logics, right? I got this. This makes sense. All right. So now what we need to do is we need to go down to the plot tools. All right. And then we're going to go down to string again. And hit add. Again, I'll move my little crosshairs. You can just click up. Oh, I thought you could. Maybe I was wrong. Well, I'm going to move it around by going to the X tab and typing in like 100. Enter. And the Y tab, I'm going to type in 200. Enter. Just to get that little crosshair to bounce down a little ways. That's where I'm going to put my string. Right above the die. And I might scroll through the images, just make sure it's always above the die. It looks like it will always be above the die. I like that. Now what I'm going to do is I'm going to pick what my string is. Under text, so you got vision tools, mathematics. Under text, you have a string tool. Functions that manipulate strings. You know what? We're going to use the concatenate string. Anybody know what the word concatenate means? It's concatenate, not concatenate. 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 It basically means take two things and put them together. Take two strings and put them together. So what I'm going to do is I'm going to concatenate, and then I need one string, so I double click concatenate, and then I'm going to put in a quotation mark, and I'm going to write the count is, and then I'm going to put a space and another quotation mark. The count is with a space after the is. That's leaving myself a little bit of room between where I'm going to actually have the count show up. Now concatenate, the way it works is it takes two things and puts them together. So what's the other thing I want with this? I need to put a comma, the result of the blob count. So I need to go into the blob tool and get the blob count. And I'll go ahead and burn a copy of this and put it up on the board so you guys can see what's going on. Open up Word. So here's what I did.
Yes, the count is spaced.
Yeah. Can you guys see that? Is that good enough? Layout, orientation, landscape. So what I've done is I've concatenated a string called the count is. The reason I put that space there is so that when the blob count comes in, there'll be a space and then the number. Instead of saying the count is and then have a 5 right next to is, right? I have a space in there to make it make sense, right? So I believe that's going to concatenate my strings. And so now I'm going to go ahead and hit enter. When I do that, I'm going to change my setting to get bigger text because I can't see it. My eyes are horrible. And then I might even move my X value over a little bit so it's a little centered on the die. That looks like $1,000,000. And now as I scroll through these, the count is 5. The count is 1. The count is 6. The count is 4. The count is 2. Now I'll tell you what, when we did this in the lab, do you see this one right here? People would do this one in the lab, and they'd get a count of like 8. Does anybody know why? The bicycle would show up as blobs. Now, and if that ever happened, you could go into your blob tool, and you could set a minimum maximum blob area, because the dots have a lot more black pixels in them and black pixel area than the letters do. So that's one of the ways we could filter that out. We don't have to worry about that because it just worked for us. Now when I go through this string tool, I scroll through these, count is 3, 5, 1, 6, 4, 2, so on, so on, so on, so forth. You guys feel pretty good? Is that not the coolest thing ever?
It's up there.
I like that they use layman terms like blob.
Like layman terms like blob and concatenate. I am going to concatenate blobs. Yes, yes, they are. Yeah, it is. It's a very common vision term is a blob. You know, I wish there was a better, you know, like an island of pixels or something, you know, is what a blob is.
Concatenate was the first word I learned in here, and bigger blob would be like amalgamation or something.
Yes, yes. Should be a more interesting word than blob. Who got this one working? Almost everybody got this one working. I'm going to pause the video. All right. So now go ahead and do a file save job as. I'm going to go back to my desktop and go into the dice. I'm going to call this my dice count. My dice counter. If anybody's wondering if you've ever walked by the display case down there, it's exactly what this does. It doesn't work anymore. Something's wrong with it. We got to go down and troubleshoot it. But for a long time, you could hit that button, it would roll the die, and it would display the number on the little LCD screen.
What is the HMI?
Probably there is no HMI.
I don't know.
All right.
The button's the HMI, isn't it?
Well, the button is an HMI, really. Yeah, that's true.
HMI's got COVID, not working so long.
No, that's right. All right. If you go back into the course in Canvas, now there's Machine Vision Lab. We're gonna set it up, and then I'm gonna leave it alone. So you guys can work on it at home. You can do whatever you want with it. Be your homework. I'm gonna click on Machine Vision Lab. And so the Machine Vision Lab is to create a vision program to inspect the attached tray of chocolates. Photos attached. Identify trays that are missing chocolates. Identify trays that have undersized chocolates. And all you have to do is display pass or fail. So if you go into this candy zip, whoa, download multiple files. There we go. All right, so now I'll go into here and I'll go and copy the candies. And once I've got them out of the zip folder, I can create a folder on my desktop called Candy. Go into that folder. I can paste these in here. Feeling pretty good about that. Then I'll go into Insight and do a new inspection. I'll give you guys a second to get caught up. All right, so now that you've got your candy file saved to a location on your computer, you went ahead and did a new job in Cognex. Get connected is still under the emulator standard. We make sure we're on the PC selection here, not on a sensor. If we were looking at a camera, we'd be on sensor. Now we go to setup image. That's the next step. I always use that as my checklist. I go through that checklist. I'm going to go load images from PC. I'm going to go to my desktop. I'm going to find my candy folder. Click on OK. Click on OK.
They look like burritos.
They do look like burritos. Yes. I don't know if they're candies or burritos. You can call them whatever you want, Marshall. They can be burritos. You go to your burrito folder. Pull up your tray full of burritos. Yeah, I don't know if this is candies. I don't know if it's burritos. I don't know how big these things are. But I know there's supposed to be 12 of them there, right? Now, if you scroll through these images, what you're going to find is that one looks good. How about that one?
No.
One of those is undersized, isn't it? How about that one?
No.
One of them's off the screen.
And it's a little bit off the screen. That one's going to pose a little bit of trouble for you.
Tricky.
So you can see this one is hard. But the idea is that, you know, take it home, play with it, work on it the rest of the lab tonight, whatever you want to do. The other thing that you're going to struggle with on this is the blobs are not consistent. Meaning the dice, the dots on a die, are all the same size. If I go ahead and go now to locate part, that's easy enough to do, right? I can go to pattern. Maybe I pick that upper left corner. I make the outside box a little bigger. Maybe I pick that upper left corner to model my corner of the tray. You know, like this, so I can always find that upper left corner of the tray. Seems like that'd be easy enough to do. Then once I have that, I scroll through the images. I make sure those little crosshairs bounce around with the tray, right? All that did was what did that do for me by locating it? Created a what? Created a starting spot, a fixture, a datum, whatever you want to call it. Created a point from which all the other tools are going to be drawn. So that's going to locate all my other tools, right? So that's an important thing. If I don't have that, things can go wrong. Now the next thing I would do is say, okay, now I want to inspect the part. I've located the part, now I want to inspect the part. So now maybe I'm going to go into the counting tools and count blobs again. Double click, add it, create a rectangle where I'm going to count the blobs. I'm going to go on the inside edge of this black tray, and I'm going to look for some blobs. I hit OK, and it just gave me 29 blobs. Probably not 29 items that I'm looking for, right? You can zoom in on this thing and see what it's counting. What you'll notice that's tricky here is just on one of these little candies, it counted blob 13, 15, 6, and 27. That's problematic. I will say, though, you guys have one fix that you can put on it right away. What is that fix? Color. So I'm going to go into the color, and instead of doing either, I'm going to do white. That gave me 6, 13, and 22. So I still have 3 blobs. Now I can go to minimum area pixels. Maybe I want to make the minimum area 2,000 pixels for it to be a blob. That made this one candy only be 1 blob. So I'm looking for a minimum area of white pixels of 2,000. I just got lucky. You know, I said, well, 100,000 pixels is the max. Let me try 2,000. I could have scaled up, right? I could have started up at 500, 600, 700, 1,000, 1,500. And eventually I'm going to get to the point where when I do this, I now only get 12 blobs for 12 candies, which is exactly what I want to have. Now that being said, I have no idea if that's going to work on the other trays, right?
It does not.
I get 12. I get 10. Now this one, though, I want to fail, right? So I might go into my range limits right now, too. in that blob count tool and say, like right now it says blob count 10, but then it says maximum 29, minimum 29. Why is it saying 29? Because I was detecting a lot of blobs at first, right? What do I want my min and max to be? I want them to be 12, don't I? I want 12 candies in there. So I hit enter. This one's out of range because it's only 10. This one's out of range because it's only 7. This one's in range because there's 12. What you're going to discover, though, is some of these are going to be difficult with you. The lighting and the reflective surface makes for a very, very difficult.
You didn't take these pictures, right? I just didn't insult you.
Yeah, I went home and just made a mess out of it. These were ones that came with Cognex, so
Okay, I was gonna.
yeah.
13.
So it's just something to play with. It's a little challenging option for you guys for lab. Again, you guys can work on it tonight. You can take it home. I'm not going to tell you how to do it, but for full credit, pass if there's 12 uniform size blobs, fail if there isn't. That's all there is to it. Pass or fail. That's all I'm looking for. You can put it right on the screen. You can do whatever you want with it. What do you guys think? Pretty cool? Awesome. Well, so that concludes. I will stop the video, get this posted for the folks that couldn't be in lab tonight, and hopefully everybody will be able to work on the lab. And for those of you watching this from home, have a happy Thanksgiving. If you're watching this after Thanksgiving, I hope you had a happy Thanksgiving. And stay safe.